Welcome to this explainer. Look, we are right in the middle of a massive paradigm shift in technology. If you felt like the traditional ticket-driven software development lifecycle is just buckling under the weight of AI lately, well, you're absolutely right. We are at a critical juncture where we have to fundamentally stop just writing code and start building the systems that produce it. To really grasp the sheer scale of this transformation right out of the gate, consider this staggering statistic. As of early 2026, 85% of professional developers are regularly using AI coding tools. And it doesn't even stop there. Over half are using them daily, and it's estimated that 41% of all new code is entirely AI generated. This isn't some sci-fi distant future scenario. This is the daily reality of modern engineering today. So, let's dive into what this actually means. For decades, programming essentially meant translating human logic into machine syntax by hand, right? You had to worry about the curly braces, the semicolons, the exact precise grammar. Every single step introduced friction. But that friction is rapidly collapsing. We're entering a brand new era where intent is the interface. The machine handles the heavy lifting of implementation, while you, the human, provide the intent, the architecture, and that absolutely crucial judgment. Here is a quick roadmap of exactly how we're going to navigate this explainer today. We'll trace the shift to intent, look at the new verification bottlenecks, explore the spectrum of vibe coding, and then dive into how we actually build disciplined factory models and engineer harnesses. Finally, we'll wrap up with what this means for your new role as a developer. Okay, let's kick things off with that first point, the shift to intent, and how we've moved from basic autocomplete to full autonomy. Think about how much your own workflow has changed just since, say, 2021. We've moved at lightning speed from simple editor token prediction, where the machine was basically just guessing your next few characters, to fully autonomous agents. Today, we're dealing with systems that can independently clone entire repositories, plan out complex architecture, execute code in isolated sandboxes, run their own tests, and seamlessly submit pull requests. And they do the whole shebang without a single human keystroke. But of course, that kind of speed introduces new problems, which brings us to the verification bottleneck. This incredible implementation speed is completely exposing the breaking points in our traditional Agile workflows. Think about it. Agile was designed to shorten feedback loops, right? But AI compresses this cycle completely unevenly. While AI shrinks actual code generation from weeks down to mere hours or literally minutes, the real bottlenecks are now requirements, architecture, and verification. Those phases? They remain stubbornly human-paced. In fact, studies are showing that sometimes developers actually take longer on tasks with AI because they spend so much time just debugging and verifying the output. The implementation phase hasn't vanished, it's just transformed from writing to reviewing. So, how are engineering teams actually handling this uneven compression? Well, let's look at the vibe coding spectrum. You might have heard the viral term vibe coding, where you just kind of give in to the vibes, prompt an AI in natural language, and see if the output magically works. And hey, that is fantastic for a weekend hackathon. But you try telling a CTO your team is vibe coding the company's core payment system? Yeah, alarm bells are going to ring. Honestly, we've seen teams hit a brutal wall trying to scale AI to 33 different production initiatives purely because they treated the model like a junior developer just relying on vibes instead of structure. What you actually need for production software is agentic engineering, where the AI operates under incredibly strict human-designed constraints. The crucial takeaway here is that verification is the primary differentiator. It's not about whether you use AI, it's about how rigorously you verify what it spits out. In agentic engineering, you need two things working perfectly in tandem: strict tests to verify the deterministic functions, does input A actually equal output B? And carefully designed evaluations, or evals, to judge the AI's reasoning. Did it take the right logical trajectory? Did it use the right tools to get there? And that need for rigorous structure leads us directly to the factory model. This is the fundamental mindset shift I mentioned earlier. We have to stop manually writing the code and start building the systems that produce it. Your role completely shifts. You're no longer the manual assembly line worker tightening the bolts on the factory floor. You are now the high-level factory manager. You sit in the developer zone, designing the specifications, the tests, and the guardrails. You define the success criteria, and then you let the agents do the iteration on the floor. But if you're the factory manager, how do you actually control the machinery? Well, you have to engineer the harness. I absolutely love this equation because it perfectly captures reality. An agent equals the model plus the harness.
You have to understand that the AI model itself is merely the raw engine. A raw AI model cannot manufacture software safely on its own, any more than a loose V8 engine sitting on a garage floor can drive you to work. It desperately needs surrounding machinery to give it state, tool execution, feedback loops, and enforceable constraints. That surrounding machinery is the harness.
This harness, this is your true engineering surface area now. It's way more than just a clever prompt. It includes strict rule files that literally dictate who the agent is. It's the specific API tools you allow it to call. It's the isolated secure sandboxes where the code actually runs. It's the complex orchestration logic handing off tasks between different subagents. And crucially, it includes the deterministic safety guardrails and the observability tracing that keeps the AI from drifting off course and breaking your production environment. Operationally, the harness makes up roughly 90% of your system, while the model is just that 10% core at the center. When an agent fails, our first instinct is usually to blame the model, right? Oh, the AI just isn't smart enough yet. But the truth is, it's almost never the model's fault. It is usually a failure in configuring that 90% framework layer, a missing tool, a vague rule, a lack of guardrails. In fact, benchmark studies have shown teams rocketing from the top 30 all the way to the top 5 in agent performance without changing the model at all. They just heavily optimized the surrounding harness. With this highly structured factory model in place, let's talk about what happens to your everyday workflow, your new role. The modern developer is no longer just a typist. You now have to move fluidly between two very distinct modes. Sometimes you are the conductor. This is highly hands-on. You're guiding the AI in real time, right inside your IDE, reviewing inline suggestions, keeping fine-grained control. But other times, you have to be the orchestrator. This is asynchronous, high-level delegation. You're defining goals for background agents that might run in the cloud for hours, and you just review their pull requests later. It's absolutely vital to know when to use which mode, especially to solve what we call the 80% problem. Look, AI can rapidly generate roughly 80% of the implementation code for a new feature. But that last 20%, the complex edge cases, the nuanced error handling, the ambiguous architectural correctness, that still demands deep human contextual knowledge. You must utilize the orchestrator mode to automate that initial 80%, so you can save your human expertise acting as a conductor to solve the incredibly complex, high-value 20%. You apply your expertise where it actually matters, not on boilerplate syntax. As we wrap up this explainer, I want to leave you with a thought to chew on the very next time you open your IDE. The bottleneck in software development is no longer how fast you can type. It is entirely your ability to verify intent. So, are you going to keep writing the code, or are you ready to build the systems that produce it?